So, having discussed about the free fall motion, now I would like to break out the free fall motion into different segments. So now I'd like to see about the one-way up free fall motion where the object is moving upwards. So just that one-way up motion, it ends there. So I'd like to analyze on how we can be able to solve some sort of mathematical problems to deal with that kind of a case of the free fall motion. Let's say we have the object. And it is, in this case, let's say it is on the horizontal, actually it is on the level ground. And assuming that the object is to be thrown, let's say, upwards, in this case. So what is the initial velocity of the object? We know that it should be given as u. So initial velocity should be given as u. And you should have to understand that whenever the object has been thrown straight upwards, it won't go straight upwards forever. It has to reach at the point where it should have to turn back. So what is that point? That point is said to be the maximum point. So that is said to be the maximum point. So what is the velocity at the maximum point? So it is given as Vmax. So velocity at the maximum point, it is given as Vmax. And at that point, velocity is usually given as 0 unless otherwise, but at the maximum point, the velocity is given as 0. And what is the distance from the level ground to the maximum point? It is given as actually a maximum height given as h. Of course, some books they'll say h max. It is the same, h max or the maximum height. And what is the time it takes for the object to move from the actual level ground up to the maximum point? We say it is given as t max. So it is given as t max. That's the time for the object to reach to the maximum point. So it's given as t max. And now, what is the acceleration of the object as it is moving upwards? It is given as acceleration due to the gravity, and it is given as the negative. Mind you, whenever the object is moving upwards, acceleration due to the gravity is negative. So take note of that. So if this is the case, then how can we be able to have, let's say, the maximum height and for the one-way free fall motion up? So now the formula, mind you, free fall motion incorporates the equations of kinematics, whatever the case, because under the free fall motion, objects are said to move at a constant acceleration, which is acceleration due to the gravity. Hence, those equations of kinematics will be incorporated in that way. So we're going to use the equations of kinematics and first to analyze the motion in the free fall. So bear that in mind. And from the fact that those equations of kinematics are being used under the assumption that the object is moving at a constant acceleration. So hence the free fall motion also, those equations has to be applied because the object is said to move at a constant acceleration due to the gravity. So how can we be able to have the maximum height and therefore the object? So now the maximum height of the object is calculated using this equation. V square is equal to u square plus 2as. Now this is the final velocity, initial velocity, acceleration, and this is the displacement. So what is this equation in a free fall motion? So in this case, we'll have this one a Vmax to the power 2, which is equal to initial velocity, that is from the level ground, and I'll have minus, since now this acceleration will be the acceleration due to gravity, so have it as a minus 2g, and then I'll have maximum height, that which is this one. Then I'll have to make that h as the substitute formula, so I'll have it as, now we'll have negative 2 should be negative, so should be negative GH is given as Vmax square, and minus, actually should be minus U square, and of which you have a maximum height being given as Vmax square minus initial velocity divided by, now should be that of negative, should be negative 2g. So that's the formula that you can help you to have the maximum height of the object as it is traced at this point from the level ground. So just have to know that. And also, if we know, and also this formula can also be used if this is the case. So this formula can also be used to have the maximum height and obtained or attained by the object. We can use this formula as well. The displacement is equal to u plus v over 2 in that times t, where this is the initial velocity, this is the final velocity, this is the time. So now in this case, what is this in free form motion? We'll have h, which is displacement, will be given as u plus vmax and over 2 in the times. What is this t? This t is said to be t max, the time takes for the object from the level ground up to the maximum point. So have that understand. So which means we'll have this one as t max. So this formula also helps us to have the maximum height attained by the object, if that's the case. And or else we can also use this formula as well. That is, displacement is equal to ut plus half AD square, where now this is the actually maximum height, initial velocity, this is now t max, and the minus half GD should be GT max square. So this formula can also help us to have the maximum height attained by the object. If we know the time it takes, that is t max, and if we have the initial velocity, and be able to have that one using actually that formula as well. And how about the way you can have the initial velocity? How can we be able to have the initial velocity? That's the velocity from the level ground, if this is the case. So there are several ways in which we can be able to have the initial velocity. So we can have, should be now, initial velocity. So we can have it using this equation. That is v is equal to, should be AT, should be this. V is equal to AD plus u, where this is the final velocity acceleration, this is time, this is the initial velocity. So what is this in free form motion? So now have it as, this is the Vmax, which is equal to negative GD max, and plus initial velocity. So in this case, we'll have initial velocity being given as, now we'll have it as a Vmax and plus GT max. So take note of that. And apart from that one, you can also use this actual formula as well to have the initial velocity. That is v square minus u square plus 2as, where this is the final velocity, initial acceleration, the displacement. So in that case, we'll have, this is the Vmax square, which is equal to initial velocity minus 2gh. So now the initial velocity, which is given as u square, we'll have it as now Vmax square and plus 2gh. So now, which means the initial velocity will be given as the square root of now the Vmax square plus 2gh. This is also the formula you have to use to have the initial velocity. In the matches, we have some other parameters to be used. So that is. And I can also use this formula as well. That is a displacement should be this. Displacement is equal to ut plus half AD square, where now this is the displacement given as h, ut, this is the d max, that's the time for the object to reach at this point, and the minus half g d max square. So in this case, if we have a time and the maximum height, we can be able to have the initial velocity using that formula as well. And we also have this formula we can use to have, mind you can see that we're just playing around with equations of kinematics. So having the very beautiful basic knowledge of these equations of kinematics, it is a very brilliant idea, because they are the ones that should be used in the commonly. We also have this equation as well. S displacement is equal to u plus v over 2 in the times time. So now, where now this is the initial velocity, and this is the final velocity. Now in the actually free form motion, we have maximum height is equal to u plus, now we have this one as a vmax over 2 times time, which is a tmax as well. So take note of that. You'll be able to have the initial velocity as the subject if we have the other parameters being given. So first thing, you should have to identify what are the given parameters in the equation, then you'll be able to have it out there. So now, how about if we are to calculate the tmax? How can we be able to have the tmax for this case? So now tmax can be calculated using the formula v is equal to at plus u. What is this in free form motion? This is the vmax, which is equal to negative g dmax and plus initial velocity, where this one is the tmax we're looking for. Mind you, this is the one way up, actually free form motion, where the object is moving upwards only up to this point. And we can also have this formula as well. It will be based on the given parameters, because for this formula is going to work if we have the final velocity, of which it is given as well, unless otherwise, and if we have the initial velocity, we'll be able to have the tmax, which is just fine. So bear that in mind. And also this formula can work as well. That is, displacement is equal to u plus v over 2 times t, of which in free form motion we have it as displacement, which is height, we'll have it as u plus v max over 2, and that is times t max. So this one will be given as a t max. So you can be able to have this one if all these are given. It is okay. And how about if we have this case? And we can also have the tmax using this formula as well, which is given as displacement is equal to ut, should be ut, and plus half AD square, where now in the actual free form motion we have it as the maximum height is equal to ut max. Now this is the tmax minus half g d square max. And if we have the initial velocity height, you can be able to have actually the time. Now you can use the quadratic formula, unless if initial velocity is given as 0, that's when actually this one will be 0. But basically we are going to use the quadratic formula first to have the actual tmax. Basically, if we have the initial velocity as well as the displacement, which is the maximum height, and always you are being given acceleration due to the gravity, which is given as should be given as 9.81 meters per second, or we can have it as is actually 10 meters per second square. And basically in a college we use this actually a value, but in a secondary school or should be a high school, basically this value is what is being used most. But anyway, just have to know that. So that's how you have to understand about the analysis of the one-way up of the free fall motion, where the object is being considered to move upwards only. So the next we see on how we can be able to analyze the one-way down motion with actually the one-way down free fall motion, where the object now is moving downwards from up, actually from the up. So now, which means there's something to have to understand as well. Let's say we know that this is the maximum point the object has to actually attained by the object, but we know that the final velocity at the maximum point is given as L. But what if you were to have the velocity of the object, let's say along the way? Let's say at this point, what is the velocity of the object as it is moving up? So you'll be able to have the final velocity using the rest of the formulas that I've recently discussed about. Much as this is not the point where the object is to end. Otherwise, the point in which the object is to end, at that point, velocity is given as well. But if it happens that the object is not ending at that point, it means you'll be able to have the velocity at that point that will be regarded as the maximum. Actually, that will be regarded as the final velocity. So using the rest of the formulas, you can also be able to have the velocity of the object as it is moving upwards along the way. So bear that in mind. So we can be able to have the velocity of the object along the way using the same equations of motion, that is in cooperation with the free fall motion. So bear that in mind. So that's how you have to understand about the analysis of the motion of the object in a free fall motion where it is moving only upwards. So thank you.